This is the part 3 for the chapter 17, and we're looking at esters. Esters' name consists of two words. The first one is the name of the alkyl group R' in the ester group. The second one is the name of the parent acid with the family name ending IC acid replaced by ATE. Example. How do you name them? So on the left side, you see this part is the acetic acid, CH3COOH, but then it's going to be linked to an ethyl alcohol. On the right side, this part is a benzoic acid. You recognize it, benzene attached to COOH. The H is replaced here by the methyl alcohol. I won't ask you too many questions about this, but you may be able to find the structure acetate such as butyl acetate. Again, two word name consisting of an alkyl group name followed by an acid name with ATE ending that shows that the compound is an ester. The name acetate shows that the RCO part of the molecule is from the acetic acid CH3COH. You should know the acetic acid formula CH3COH. Sometimes people name it at HO-AC for acetic acid. The butyl part of the name indicates that you have butyl group that has replaced the H from the carboxyl group. So this is here the solution. You have here on the left side CH3COO, no H because it's attached to a butyl group from the butyl alcohol. Next, we're looking at amide. Well, they have a nitrogen atom that is attached to the carbonyl atom, and we call those amide. The nitrogen of an amide may be either NH2 group or may have more R' group bonded to it, depending if it's primary, secondary, tertiary. The ones that are unsubstituted, such as RCONH2, can form multiple hydrogen bonds to other amide molecules. Just make sure you pay attention to the distinction between amines and amides. The nitrogen atom is bonded to a carbonyl group in the amide, not in the amide. So other characteristic amides are not as basic, meaning that the pH goes from 8 or above 7 to 14. So here, amide that have an unsubstituted NH2 group are named by replacing IC of the acid by OIC acid of the corresponding carboxylic acid, and we name them with amide. If your nitrogen atom has an alkyl substituent attached to it, then the compound is going to be named by specifying the alkyl group and then being able to identify the amide name. Alkyl substituents are preceded by the letter N, just to remember and make people aware that they are attached directly to the nitrogen atom, which is N for the symbol. So there are just a basic reviews of the derivative of acetic acid. You should know those, such as methyl acetate, which is an ester, acetamide, which is a primary amide. A secondary amide, you need to see where it's attached to the nitrogen atom, so it's a methyl attached to the nitrogen, so it's N-methyl acetamide. N-dimethyl, because it's attached here, you have two methyl, so dimethyl attached to the nitrogen atom, acetamide. And N-ethyl and methyl acetamide, those are tertiary amide. Then I let you read the properties of the carboxylic acid esters and their amide. Last thing I want to talk about is carboxylate anion. The anion that result from the ionization of the carboxylic acid, and the end is COO-. They are weak acid, they establish equilibria, and this is just example. I will not ask you too complex questions about this, but just recognize that when you have an acetic acid, such as the top one, reacting with H2O, the water molecule, you get an acetate ion. Characteristic, you see that instead of having OH at the end, you have O- because that hydrogen bound to the water molecule to give H3O+. Bottom pyruvic acid will give you pyruvate ion.